All right, let's talk about one of the most important parts of building modern applications, securing your API. Today, we're going to zero in on one of the most common and powerful ways to do it, the bearer token. We'll break down how this one concept acts as the digital gatekeeper for your app. Let's get into it.
So, picture this. You've just spent all this time building an incredible API. It's fast, it's efficient, it's ready to go. But, hold on a second. Who can actually walk up and start using it? Well, if you haven't set up any kind of authentication, the answer is pretty much anyone. The front door is wide open. So in this explainer, we're going to learn how to install a really solid digital lock. And our key to that lock is the bearer token.
So what even is a bearer token? The absolute best way to think about it is like a digital keycard system, just like you'd use to get into an office building.
Okay, so the official technical term is bearer authentication, and it's built on a super simple idea. Access is granted to whoever bears or holds the security token. If you show up with a valid token, the door opens. No token, no entry. It's really that straightforward.
And this right here is the heart of the whole concept. It's not about who you are, it's about what you have. The server doesn't need to know everything about you for every single request. It just needs to see that you have a valid keycard, which makes the whole process incredibly fast and efficient.
Now, one of the biggest advantages here is that tokens are stateless. What does that even mean? Well, in an older stateful system, the server has to keep a running list of every single user who is currently logged in. With stateless tokens, the server doesn't have to remember anything between requests. Every request you send comes with its own proof, the token, which makes it so much easier to scale your app across lots of servers.
Okay, so we've got these digital keycards. But where do they come from? Who's making them? Well, that's the server's job. Think of your server as the front desk of the building. It's the one responsible for creating and handing out these keycards.
And the process works like a little four-step dance. First, you send your username and password to log in. The server checks them. If they're correct, it generates a special, signed token, usually a JSON Web Token, or JWT for short. And finally, it sends that shiny new token back to you to hold on to.
And believe it or not, this one little line of code is where the magic happens. The server takes some data, like a username, signs it with a secret key that only the server knows, and then sets an expiration time, in this case, 1 hour. And just like that, you have a secure, temporary keycard.
But the server's work isn't done, not even close. Issuing the key is just the first part. For every single request to a protected part of your API, the server also has to play the role of the bouncer. So how does it act as a bouncer? It uses something called middleware. You can think of it like a security checkpoint. Every incoming request gets stopped and checked. The middleware looks for an authorization header, pulls out the token, and then uses that secret key to verify it. Is the signature real? Has it expired? If it all checks out, the request goes through. If not, it's denied.
So we've covered what the server does, it's the front desk and the bouncer. Now let's flip over to the other side. What does the client, the one holding the key, actually have to do? You know, the client's job is actually pretty simple. After you get that token from logging in, your only responsibility is to store it securely and then include it every single time you make a request to a protected resource.
And how do you include it? You use a standard HTTP header with a very specific format. The header name is authorization, and its value is the word bearer, followed by a space, and then the actual token itself. And here's what that looks like in a real request. You've got your standard GET request, and right there in the headers, you see that authorization line presenting the token. This is exactly what the server's bouncer middleware is looking for.
Now, having a lock system is fantastic, but only if you use it the right way. A keycard is only secure if you don't leave it lying around for anyone to pick up. So let's go over the essential rules for protecting these digital keys.
Okay, these are the non-negotiables. First, always use HTTPS. That encrypts everything, including the token. Set a short expiration time, use a really strong, complicated secret key, and store it safely. Never just type it into your code. On the client side, store the tokens somewhere secure, like an HTTP-only cookie. And finally, consider advanced stuff like rate limiting to block attacks, and maybe even a blacklist to manually revoke a token if it gets compromised.
Let's just focus on that expiration time for a second, because it's so important. If a token ever gets stolen, a short lifespan seriously limits the amount of damage that can be done. 1 hour is a really common standard that balances security with user convenience.
So let's just recap the whole thing. Why do we go through all this trouble? Because bearer tokens give us 4 huge wins. They're stateless, which helps us scale. They're pretty simple to implement. They are very secure when you follow the rules. And they're interoperable, meaning your web app, your mobile app, and other services can all use the exact same security system.
And there you have it. That's the blueprint for installing a digital lock on your API. With your data protected and your endpoints secure, the only question left is, what amazing thing are you going to build next?